Hi, hello everybody. So this is the second video dealing with complex numbers. And now, after we've covered the evaluation, addition, subtraction, and multiplication, we'll take a look at how division is done in complex numbers. So let me show you my notes here that you have access to on this video. Again, keep in mind that, I squared is -1. So there's going to be two types of divisions that we're going to see. The first one is when we are dividing a number, like what you see here, or a whole complex number by a single term. So here I have I, 3i, or 2i. So this is going to be one technique. So the technique for that is you are going to multiply numerator and denominator by the quantity I. Okay, so that's technique number one. So if you have a single term as your denominator, you're going to multiply both numerator and denominator by this quantity, and then we'll simplify as we go. The second type of division is if you're dividing by two terms. Okay, and I'll show you an example in a few minutes. So this technique is called the conjugate technique. The conjugate is, as you see here, if I have a term that is 5 minus 2i, the conjugate of that is 5 plus 2i. If the term is minus 3 plus 4i, the conjugate would be minus 3 minus 4i. So the conjugate is pretty much the same two terms, but with the opposite sign in the middle. Okay, so whatever the sign of the I factor is, you're going to flip it. So minus 2i becomes positive 2i, positive 4i becomes minus 4i. And then we're going to multiply numerator and denominator by that quantity. Okay, so first let me show you the very, very simple case of when we have this case, division by a single term. So I'm going to do all three. This is very, very easy. So here is 5 divided by I. It's a single term. I am going to multiply by I over I. Okay, so numerator 5i, denominator I square. Now keep in mind, as we said before, whenever you see I square, you have to make a substitution. So this will be 5i divided by minus 1, which is obviously, don't leave a minus at the denominator, so that will be minus 5i. Now, the main thing, once you've done, this procedure, you have to note that at the end, we can't have an I in the denominator. Okay, at the end, we cannot end with an I in the denominator. So this whole division process is pretty much like when we end up with a minus as my denominator, so that minus has to go up. It cannot stay as the denominator. So in this case, I'm done. Okay, so same thing with 15 divided by 3i. There's a single term here, so you're going to multiply by I over I. If you wanted to, you could multiply by 3i over 3i, but I over I is just easy. So numerator 15i, denominator 3i square. Okay, so I can do 13 divided by 3 is 5i. And now, remember, this is minus 1. Okay, so again, move this thing up, minus 5i. Okay, so a single term is very straightforward. We'll do the last one for you to see, which is 4 plus 6i divided by 2i. If you want, you can split it into 2. 4 divided by 2i, 6i divided by 2i. Okay. So this is one approach you can do. You can divide them individually. And notice that in this case, I have an I in the denominator, so I have to multiply 4i and then 2i times I, right? If you didn't see it, I'll do it again. You missed it. So this is 4 over 2i times I over I. But notice that in this case, I don't need to do it because the i's cancel. And I have 6 over 2, which is 3. So I don't need to do that one. But the first division I do. So this is 4i divided by 2i squared. And here's my plus 3. So obviously this is minus 1. Okay, so I have 4i over 2 times minus 1, which is minus 2. So 4 divided by negative 2, obviously negative 2, and here's my I. Now, here's my positive 3. Okay, and write it in the normal way, which is number first and I factor after. All right. So this is one way you could have done it. If you wanted to and follow the standard procedure, you would do this. I'll do it again for you to see. 4 plus 6i over 2i times I over I. That might be easier for you. So remember there's parentheses here. So this is 4i, 6i squared, 2i squared. This is obviously negative 1. So I have negative 1 times 6 is negative 6 plus 4i divided by, this is negative 1, negative 2. Right? And then we do each division. Negative 6 divided by negative 2. 4i divided by negative 2. So obviously this is 3. And 4 divided by negative 2 is negative 2. So it's same answer. So it doesn't really matter which way you want to do it. It's perfectly fine. Okay. So this is the first type where we have a single term as our denominator. Now, what if we have, so this is the first example I showed you. It's the exact same thing. What if I have 2 now? So if I have 2, as I said, you're first going to find the conjugate. And then you're going to multiply numerator and denominator by that conjugate. All right, so let's take a look at this example here. I have 3 minus 5i divided by 7 plus 6i. So the conjugate is always the conjugate of the denominator. Okay. So if the denominator is 7 plus 6i, the conjugate would be 7 minus 6i. So look what we have here. So we leave the question as it is, and we multiply numerator and denominator by the conjugate, which is 7 minus 6i. So we have to FOIL the numerator. We have to FOIL the denominator. Eventually, the denominator, once we FOIL and we replace the I squared by minus 1, the I factor will disappear. And at the end, remember what I said before, that the denominator or denominators cannot have any I factor, as in this case. Okay, so let's take a look. I will do a couple of these problems. So we can do 2218, which is 4i divided by 2 plus 5i. Do it over here. I didn't copy this. 4 divided by 2 plus 5i. All right. Just make sure that this is the problem, but it doesn't really matter. I mean, these are very, very 4i divided by 2 plus 5i. All right, so I have two terms as my denominator. The technique is the conjugate. The conjugate is the conjugate of this term. So the conjugate is 2 minus 5i. So I have to multiply numerator and denominator by the conjugate. Keep in mind there's an invisible set of parentheses here. Okay, so distribute the 4i as we normally do. So I have 4i times 2, 8i, and 4i times negative 5i minus 20i squared. Okay. The denominator we have to FOIL, but something special is going to happen. The two middle terms will cancel. So 2 times 2, 4. 2 times minus 5i minus 10i. 5i times 2, positive 10i. And 5i times negative 5i minus 25i squared. So look, minus 10i, positive 10i cancel. This is always going to happen when you multiply by the conjugate. Remember, this is minus 1. We have to make that transition. Anytime you're dealing with complex numbers, you must remember this. So I will have 8i minus 20 times minus 1, positive 20, and I will rewrite it in the proper order next time. So I have 4 minus 25i squared. And this is negative 1 as well. So 20 plus 8i. And I have minus 25 times minus 1 is positive 25. So 4 plus 25, which is 29. Okay, and then we split it to leave it in normal complex number form, and this is our answer. Okay, so division of complex numbers where we have the denominator having two terms. Conjugate approach. Okay, let's do one more. Take a look here. And we'll do one more. Maybe we can do the last one. 8 plus 3i minus 2 minus 5i. So let's see. 8 plus 3i. Is it minus 2 minus 5i? Let's confirm. 8 plus 3i minus 2 minus 5i. Yes, it is. Okay. Again, I see two terms here. So I need to multiply by the conjugate. The conjugate is always the conjugate of the denominator. So the conjugate would be minus 2 plus 5i. Okay. It's always the opposite sign of the I factor. So if it's minus 5, it would be plus 5. If it was plus 5 here, it would be minus 5i there. So minus 2 plus 5i, parentheses, parentheses, minus 2 plus 5i, parentheses here, parentheses all over. So in this case, I have to FOIL both numerator and denominator. So let's do that. So I have 8 times negative 2 on the numerator minus 16. 8 times 5i plus 40i. 8 times 5i plus 40i. 8 times 2 plus 5i plus 20i. 8 times 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 8 times 2 plus 5i plus 40i plus 20i. 3i times minus 2 minus 6i, and 3i times positive 5i plus 15, and you know it, I squared, right? I times I, just like x times x. Okay, next time around, I'll combine like terms and I'll replace the 15i squared with 15 times minus 1. Now, the denominator is a special case again, and the denominator will have both middle terms canceling. And I'm going to do it here on the side so that you can see. So I have minus 2 times minus 2, positive 4, minus 2 times plus 5i, minus 10i, minus 5i times minus 2, positive 10i, and minus 5i times positive 5i minus 25i squared. Again, notice these two cancel. And I have 4 minus 25i squared, and this is going to be minus 1. So I'm going to write it here, 4 minus 25i squared, just for now. So minus 16, 40i minus 6i, that is 34i. And here's my positive 15 times the negative 1, which is minus 15. Same thing here. I have 4 minus 25 times minus 1. And this is, again, my 4 plus 25. Negative 16 minus 15 plus 34i. And here's my 29. And then I write it. I write it in complex form. 31 over minus 21 over 39 plus 34i over 29. Okay. So if you have two terms as your denominator, you're going to employ the technique of the conjugate. If you do not, and you have a single term, as you do over here, you're just going to multiply by I over I. Okay? Always remembering that if you do have an I square, you have to make the substitution, because at the very, very end of the procedure, as I mentioned before, okay, let me remind you, at the very end of the procedure, we cannot have an I or I square in the denominator. So that ends the process of the division of complex numbers.